Hi. So we've been discussing the Big Bang, but what happened between the big explosion that threw subatomic particles into the air and made everything in this universe possible, and today? We can look in our past a day or two, we can think about what's going to happen in the future, but is there a way of looking all the way back through time to that point by using what science has told us about? We have a timeline, so we can start where we're at now and look back. So this is where everything starts. This starts with us, looking back through time. This little white line here is all of human history. Everything from the time our ancestors crawled out of the Great Rift Valley, through the Egyptians, through the Abyssins, through the Greeks, through the Romans, through all of our human history, this tiny little white stripe is here. So now, let's go for a walk and see what's happened back here. So we're gonna go back 1 billion years, 2 billion, 3 billion, and at 3.5 billion, this is the first complex life we know that has existed on our planet. It's cyanobacteria, and it's all the way back here at 3.5 billions. Doesn't seem like we've gone very far on the great spectrum of this timeline. So now we're gonna go back just a little bit more. Just a little hop, boop. In that hop, this is when the moon arrives. Science believes that the moon was a large astral body, maybe even another small planet that crashed into our planet, broke off a part of it, and then formed in an orbit. So we have these two orbs that are just moving around each other. Now we jump back another billion years, boop, and now we're at 5.5 billion. This is when our Earth formed. There was no moon at this time. That hadn't hit us. That's still 1 billion years in the future that we have to go through. So now we're looking at our Earth forming. The Earth was way different. It was super hot, full of volcanoes and poison, toxic gases. There's no way we could have existed on that planet. Just a little bit more past that, another 500 million years. Now we're looking at the formation of our solar system. At this point, all of the planets are starting to orbit around the sun, and the solar system we know today is forming at this point. Take a little stroll back another 1 billion years. Now we're looking at our sun. Now this is before there were any planets. Our sun was just a baby star out there, and it was big and it was full of fire, and then it exploded. And by blowing itself out, it blew all sorts of elements and matter out into space, but its gravity held it in place, and it turned into those planets we were just talking about a little earlier. One of those planets would become Earth. That Earth would get cyanobacteria, and then eventually we get to come along. Now we got a little bit more of a long walk to go through. Oh, okay, this is a tough one. Go another billion, and another billion, and another billion, and another billion. Whoa, there's a lot of billions, and another billion. Now where all the excitement happens. This is where everything that make us who we are today started. At about 13 billion years ago, galaxies started forming. Go back just a little bit, 13.3 billion, the first stars. So stars are just giant balls of gas, but galaxies have other planets and other solid objects that are floating and spinning and orbiting around those stars, so that they have gas giants and all sorts of craziness going on out there. Just before that, before you can have stars, before you can have matter, matter has to form. And the first matter you see forming is hydrogen. Hydrogen, the first element on our periodic table. That's the first matter that forms, and that's 13.5 to 13.7 billion years ago. Just before that, very interesting period that science just recently thought of, there was a dark ages. So after the big explosion, all those particles exploded out and were evenly distributed throughout our universe. Over time, they got lonely and they wanted to find each other, and they started to find each other. And as they started to form, all those subatomic particles bouncing into each other and crashing and bashing, and then elements were forming from that. And then the entire universe lit up and caught fire because hydrogen was the first element formed, and it is very flammable. So right after the Dark Ages, the entire universe was on fire. Now, this is where it gets neat again. Before all of this could happen, and all of that energy that creates our entire universe starts, we have to go through the cosmic inflation, which we know is the Big Bang. But what banged? What inflated? What exploded? We call that the singularity. It's something science is still trying to figure out exactly what it is, but right now we believe all matter in the universe had concentrated down to a single point, to a single mass that got so dense and so solid it couldn't handle all the force that was being exerted on it by itself, and then it went and inflated out. It just exploded out everywhere. The second that happened, the four fundamental forces that guide our universe, like gravity is one, suddenly came into being. All of a sudden, it was all there, laid out, so that our entire long future could happen. And because of those forces, protons and neutrons were formed, the building block of atoms, the building blocks of matter, and from there, we have our entire history laid out before us, all the way to that little teeny tiny white stripe. That's us. Hope you liked it. Bye. Oh, I just realized something. Mr. Bones wasn't with us today. He's been out practicing with the theremin because he wants to make sure that we're really sharp when that experiment comes through. What's a theremin? You'll have to wait and see.